as you saw in the video. A new computing model rarely comes about. It takes an enormous amount of time and set of conditions. We invented this computing model because we wanted to solve problems that general purpose computers, normal computers, could not. We also observed that someday transistors will continue, the number of transistors will grow, but the performance and the power of transistors will slow down. That Moore's law will not continue beyond, limited by the laws of physics. And that moment has now arrived. Dennard scaling has stopped. It's called Dennard scaling. Dennard scaling has stopped nearly a decade ago. And in fact, the transistor performance and its power associated has slowed tremendously. And yet, the number of transistors continued. We made this observation a long time ago, and for 30 years, we've been advancing this form of computing we call accelerated computing. We invented the GPU. We invented the programming model called CUDA, and we observed that if we could add a processor that takes advantage of more and more and more transistors, apply parallel computing, add that to a sequential processing CPU, that we could extend the capabilities of computing well beyond. And that moment has really come. We have now seen that inflection point. Accelerated computing, its moment has now arrived. However, accelerated computing is a fundamentally different programming model. You can't just take a CPU software written by hand, executing sequentially, and put it onto a GPU and have it run properly. In fact, if you just did that, it actually runs slower. And so you have to reinvent new algorithms. You have to create new libraries. You have to, in fact, rewrite the application, which is the reason why it's taken so long. It's taken us nearly 30 years to get here. But we did it one domain at a time.